Hello everyone, my name is Nikita. I am from EC branch. My subject is lag and my topic is Lagrange's mean value theorem. Lagrange's mean value theorem. Lagrange's mean value theorem is a further extension of Rolle's mean value theorem. The theorem states that if for a curve between 2 points there exists a point where the tangent is parallel to the secant line passing through these 2 points of the curve. The Lagrange's mean value theorem is sometimes referred to as only mean value theorem. What is Lagrange's mean value theorem? The Lagrange's mean value theorem states that if a function f is continuous in the closed interval a comma b and differentiable in the open interval a comma b, then there exists at least one point c in the interval a comma b such that the slope of a tangent at a point C is equal to the slope of the secant through the endpoints of the curve such that f dash of C is equals to f of b minus f of a by b minus a. What is the condition for Lagrange's mean value theorem? The Lagrange's mean value theorem is defined for a function f is continuous over a closed interval. The Lagrange's mean value theorem and the differentiable over a open interval a comma b. The condition for the Lagrange's mean value theorem is that there exists a point C in the interval a comma b such that f dash of C is equals to f of b minus f of a by b minus a. How do we know if a function satisfies Lagrange's mean value theorem? The function f of x is said to satisfy Lagrange's mean value that f dash of c is equals to f of b minus f of a by b minus a, then there exists a point C in the interval a comma b which satisfies. This has been derived from the slope formula of a coordinate geometry and the slope of the tangent through the point C of the curve f of x is equal to the slope of the secant line through the endpoints a and b of the curve f of x. Graph for Lagrange's mean value theorem. The Lagrange's mean value theorem can be understood geometrically by presenting the graph of the equation as y is equal to f of x. Here the graph curve of y is equal to f of x is passing through the points a comma f of a, b comma f of b, and there exists a point C midway between these points on the curve. The slope of the secant line passing through these points a comma f of a, b comma f of b is f of b minus f of a by b minus a, and the slope of the tangent line touching the curve at the point C comma f of c is f dash of c. Further, the Lagrange's mean value theorem states that the tangent at a point C comma f of c is parallel to the secant line passing through the point a comma f of a, b comma f of b, and their slopes are equal. Hence, we have f dash of c is equals to f of b minus f of a by b minus a. Proof for Lagrange's mean value theorem. Statement. The Lagrange's mean value theorem states that if a function f is continuous over a closed interval a comma b and differentiable over a open interval a comma b, then there exists at least one point C in the interval a comma b such that the slope of the tangent at a point C is equal to the slope of the secant through the endpoints of the curve such that f dash of c is equals to f of b minus f of a by b minus a. Proof. Let g of x be the secant line to f of x passing through the points a comma f of a and b comma f of b. We know that the slope of the secant line is m is equals to f of b minus f of a by b minus a, and the formula for the second line is y minus 1 y minus y1 is equals to m into x minus x1. Further, the equation of the second line is as follows. Since the equation of the second line is g of x is equals to y, we have equation 1, g of x is equals to f of b minus f of a by b minus a into x minus a plus f of a. We can consider it as equation 1. Let us define a function h of x which is the differentiable between the curve f of x and the second line g of x such that we have h of x is equals to h of x minus g of x. H of x is equals to f of x minus g of x. Here we apply the value of g of x from the above equation. We can see the equation. H of x is equals to f of x is minus f of b minus f of a by b minus a into x minus a plus f of a. Here let us consider the function h of x is continuous on a comma b and differentiable in a comma b. Thus, applying the Rolle's theorem, there is some x is equals to 0 in the interval a comma b such that h dash of c is equals to 0. Applications of Lagrange's mean value theorem. Lagrange's mean value theorem has several applications in mathematical interpretation, computational calculation, and other areas. Lagrange's mean value theorem can be applied to determine the increasing and decreasing nature of a function as follows. A given function says f of x is continuous in the closed interval a comma b, differentiable in the open interval a comma b, and derivable of f of x is greater than 0 for all x in the open interval a comma b. Then f of x is strictly increasing function in the interval a comma b. Similarly, if a given function f of x is continuous in the closed interval a comma b, differentiable on open interval a comma b, and derivable if derivable of f of x is equal to 0 less than 0 for all x in the open interval a comma b, then f of x is strictly decreasing function in the interval a comma b. If in case of derivative of f dash of x is 0 at all locations of the interval a comma b, then the function f of x is fixed on the interval. That is, if we take any 2 points q1 and q2 in the interval a comma b, then the point c belongs to a comma b. Point to remember, Lagrange's mean value theorem would fail if any of the conditions are not satisfied. Thank you.